So in this video we're going to go through the cosine rule. Now cosine rule is split into two parts. We can talk about finding sides or we can talk about finding angles. So to find sides, here are three forms of the equation put together. It kind of looks like the Pythagoras' theorem because that's where it derives from. So just make sure you put that in properly. On the class path, there's also the e-activity function that we can use. So I'll just tap into that for a second. I'm just going to open it. So file open. Here we go, cosine rule. Now when you put it into cosine rule, it's really similar to the sine rule function, where you have to press the I button. So when you press the I button, this will look like it only solves for one of them, as in one side. But what you can do is just rearrange the letters so that you can find the side that you need. Okay, so find the third side of a triangle ABC, given that we have A, C, and B. Now, we're trying to find B here, but just to make it convenient for us to put it into the calculator, I'm going to change this to A. Sorry, I'm going to change this to A, and then I'm going to change this to B. It doesn't matter how you rearrange it, so long as you put it incorrectly into the calculator. So, if you were solving this by hand, I'm just going to show you both. We have b squared equals to a squared plus c squared minus 2ac times cos of b. The two letters here have to be the other letters that we're not using to solve, and that one, the b, has to be the one that we're finding. So similar to the sine rule, it has to be a capital B for the angle and a small b for the sides. So if we're doing this by hand, we need to use the a squared one. A squared is equal to b squared plus c squared minus 2bc cos a. Remember, these two letters have to be different. They have to be the ones that we're not solving for. And in this case, we're solving for a, so we need this one to be a capital A. If we were to solve this by hand, we would have a squared equals to 6 squared plus 10 squared minus 2 times 6 times 10 cos of 76 degrees. Now just remember, because this is a squared, we need to actually solve for it with with the square root. So we have 6 squared plus 10 squared minus 2 times 6 times 10 cos of 76 degrees. Make sure this matches with your calculator when you put it in, because if you put it in incorrectly without the brackets, you will get it incorrect. Okay, so just to show you with the calculator, we're trying to find small a, and we're looking for, with the keyboard, we're looking at b equals to 6, c equals to 10, and then a being 76 degrees. And then press solve on the top, and you can see our value being 10.34. If you put what I've put in previously on the screen, you should get the same solution as well. So putting this back onto the slide, we have a equals to 10.34. The other way we can use the cosine rule is to find angles. So again, there are three different forms. The right hand side is the one that we need. These are just rearranged versions of it. So we are, you can see it on the screen. Okay, so find the smallest angle in the triangle with four sides of 4 centimeters, 7 centimeters, and 9 centimeters. So the one with the smallest angle is the one opposite to the smallest side, which is a 4. So we're going to solve for a here. So using the previous slide, we have cos A equals to b squared plus c squared minus a squared over 2bc. Putting the values in, we have cos A equals to 9 squared plus 7 squared minus 4 squared all over 2 times 9 times 7. And then if we rearrange it and we want to use it for the calculator, we need to use cos inverse. So then 9 squared plus 7 squared minus 4 squared all over 2 times 9 times 7. Now don't forget to put this bracket in when you're putting it into the calculator. If you don't put it in, sometimes it will mess up the answers. So just to show you an E activity, this time we're trying to look for big A, so we're just going to put, we're going to tap on big A. We have small a being equal to 4, b being equal to 9, and c equals to 7. Using solve, this will give us the solution again, which is 25.21. So again, just writing the answer in here, we have 25.21 degrees. Remember, if we need to put it into degrees and minutes, we can use the DMS function to look for that. Okay, so sometimes we need to use the sine rule and sometimes we will need to use the cosine rule. Now, we're not going to tell you when each one should be used in an actual test situation, so you need to judge for yourself. Here are some helpful hints just to help you. The sine rule should be used if you have given a pair of values. So for example, I'm just going to draw two triangles here just to show you when you can be given. So let's say, whoops, not theta. Let's say you're given that this is 35 degrees and you're told that the side here is 7. Okay, that will be what I mean with the first line, where you have the given values of each of the sides, a pair of sides given to you with the angle. So they're matching it in opposite sides. So like so. And then if you have an angle that you need to solve for example here, and you're also given the length of a side, or you're given that the angle here is 50 degrees, and then you want to look for the side here, then you should use the sine rule. So the one that I put on the left hand side with the triangle here, this is missing an angle, and this one here is missing a side. So for the cosine rule, you should only use the cosine rule if you're given all three sides and you need to find one of the angles, or you're given two sides and then you need to try and find the missing side with the angle given to you. So let's just draw both scenarios out. If you're told that this is 4, 5, and 6, and then you want to find this angle, you can use the cosine rule. Alternatively, if you're told that this is 6 and 7, you're told that this is 50 degrees, but then you want to find this side here, then you can use the cosine rule. So just make sure you distinct the differences between the two.